we need to setting the power to the 30 kilowatt, 30 watt. And then we set for airflow is 3 meter per second.
Okay, this is T1, which is inlet temperature. It connects with the inlet temperature here. And then second is the T2, which is connects with the surface temperature. And then T3 is probe, connects with this probe. Okay, so since we're doing the pin force convection, so we have to push through one of the hole here. We have 6 holes, so we have to push it and make sure it connects with the pin, one of the pin, and then since we already adjust the power and the airflow, we just have to wait for the result to come, like that. Okay, that is for the first hole. Okay, second is for the second hole. Just repeat the same method and then wait for the result to come. And then the third hole, same. Make sure it's stabilized before you collect the data. The fourth hole, also use the same method. And then the fifth hole, also use the same method. And then lastly, the sixth hole, the last one. After you collect the experiment data, now you can switch off, and then you can change to the fin force convection.
To change the plate, we have to close this, plug the T2, open this, like this, plug it out, yes, then unscrew 2 screws, 1, 2, 5 bed, it's okay. Something like this. And this is a pin. This is a pin. So we plug like this. Make sure this is right side up. Okay. We only use 2 screws, 1 on top. Back. Over here, plug this in, screw it, plug in, and you're done. Just repeat the step again.
Okay, selepas kita setting dia punya airflow dan power,
kita akan tunggu 10 minit untuk bagi pin dia ni sejuk. Okey, selepas 10 minit kita akan ambil data untuk ke 6 lubang. Di sini kalau anda boleh lihat, kita ada 6 lubang. Dan setiap lubang ni kita perlu cocokkan dengan indikator haba ni.
Probe.
Untuk dapatkan suhu pin. Okey. Untuk lubang yang pertama, kita cocok sampai rod tu dia sentuh kepada pin. Okey. Kemudian kita tengok pada data ni T1, T2 dan T3 dan kita catat dan ulang prosedur yang sama untuk lubang yang seterusnya. Assalamualaikum warahmatullahi wabarakatuh. My name is FITRI bin Muhammad Amin. Okay, today I want to explain for the discussion for this experiment, force convection. Okay, from the question for discussion 1, create a chart of temperature against probe position along the pin or fin at the free and forced convection result. Okay, this is the result for the pin and fin from the experiment. So the question asks us to create a chart. Okay, this is the chart for the forced convection and the free convection. As we can see, the chart is directly proportional. Okay, next, question 2. The question asks us to calculate and compare the difference in gradient between free and forced convection for each phase. Okay, for the forced convection, we use this formula to calculate the gradient. So just insert the data into this formula and we calculate. We get the B. For this forced convection, we get the gradient which is 0.1171. Okay, for the free convection, we also use the same formula and we get the gradient for the free convection which is 1.2068. Okay, by comparing the free and forced convection of the pin surface, we can conclude that the both of the gradient of the graph are positive correlation, where the forced convection, the temperature affected by the position of the probe. As shown in the graph, the temperature increased steadily at each position. Simultaneously, the free convection of the pin surface of the temperature were also affected by increased power applied. As shown on the graph, like the temperature increase as the power increase. Okay, thank you.
Assalamualaikum. My name is NURYN BINTI YATIM. Matrix number B09201007. So I will continue with this discussion number 3. What can you say about the difference and which type of convection give a better spread of temperature along the extended surface? From the experiment, we got a forced convection give a better spread of temperature along the extended surface because it's known that forced convection is a mechanism that allows fluid motion is generated by external source. So the difference between free convection and forced convection are for the free convection, any fluid motion is caused by natural means such as buoyancy effect like risk of warmer fluid and fall for the cooler fluid. While for the forced convection, fluid is forced to follow over a surface or in a tube by external means such as a pump or a friend. Next, we go to question number 4. The extended surface is made of stainless steel, which is a relatively poor conductor. How would using aluminium or copper will affect the temperature gradient and the overall efficiency? If we use aluminium and copper for the extended surface, the temperature gradient will increase and we need to wait for a few minutes only to stabilize the temperature because all we know the aluminium and copper is a better conductor due to their free electron. That's all from me. I will pass it to my next member. Thank you.
Assalamualaikum and good evening to Sir Zahir and fellow friends. So I'm going to continue with the last one, which is conclusion. Conclusion for this lab. So based on this experiment, we actually execute the force convection lab using two extended surface, which is pin and fin. For both experiments, we're using a stainless steel material. After adjusting the power at 30 watts and the airflow at 3 meters square per meter square, we managed to find the value of temperature distribution, which is gradient, along with the pin and fin heat transfer surface in both free and forced convection. To make it short, according to the procedure, after setting up the power and airflow, we can collect all the data for inlet temperature, which is T1, surface temperature, which is T2, and probe temperature, which is T3 for both surface. By moving the probe in each holes after a minute waiting for the temperature to stabilize, then we can record data. We also happen to create a chart of temperature between temperature against probe position along with the pin and fin surface. Other than calculating and comparing the difference in gradient for both convection, we also managed to state the differences for types of convection and which one gives better spread of temperature along the extended surface. Lastly, we managed to understand what will happen to the temperature gradient and efficiency if we use another material like aluminium and copper for the surface. Okay, that's all. Thank you.